Si bajo la cámara.
Okay, so we can start with this lecture on fair data in robotics. And basically, now we have a different view of marine robotics in the last years with respect to, let's say, the pioneering era. So, you talking a lot about sustainability. And in particular, in the last years, it was launched the European Green Deal. And when dealing with blue economy, blue technology, and so on, the slogan was basically keep the blue in the Green Deal. And when you talk about sustainability, you have to consider its three main pillars that are economic, environmental, and social. The economic pillar is most related to industry, environmental to marine science, and the social citizenship that is now. And industry sees the robots, started to see the robots from special tools to standard devices that are now used commonly with the robots. And changing this point of view, industry started to need standard procedures for system characterization. This could be system from the point of view of system dynamics, maneuvering performance, and so, and especially, the need of experiment replicability and quantitative performance indexes that can be measured and established in how to say, standard way. From the point of view science. The robots were seen in many cases as instrument carriers. You saw before. I said, okay, we mounted a plankton sampler, a water sampler, and so on. And basically, the robot was seen as a service, but and not as a service, sorry, as a carrier. But once the robot is felt as a reliable and effective device, the previous end users started to see it as a service. So the robot will provide me a multivariable map of the cell. And so you need, and the robot could allow, new procedures for repeatable, accurate, and adaptive in time and space, central and data collection. So, because they can provide detailed information when, where, and how data collected. This is different than if you have somebody going in a place and collecting water. This guy or girl can tell you, okay, I did it in these conditions. But in this way, if you use a robot, you can have, if you have the telemetry of the robot, you can have available all the information about what the robot was doing, in which conditions, when it collected the data. And from the point of view of citizens, the robots are moving from being machines to companions. In the case of software robots, we live with a lot of robots. All the assistance applications that we have in different kind of things are robots. When you pay the highway, you have a robot telling you, put the card inside, put the ticket, put the card or the money, please go on. And this is a robot. But it is not a physical mechanical robot. We are moving in this direction. And what is important is to engage the citizens in the research process. But for marine scientists, it is basically quite easy. You develop an app and they say, okay, if you are walking in this natural area and you see something, a vegetable or an animal that it looks like strange to you, take a picture, send us to this site, and we will check if this is a local or an external species and so on. In the case of robotics, it is more difficult because it is the research to carry out is quite technical, involves mathematics and so on. So one open question is how to involve people in the research process. And one way we started to use is to use AI-based methodologies for citizen-designed robot control systems, especially to use algorithms for learning by imitation. So we made some experiments with the people piloting the robot and doing something, and this learning by imitation system learned by the many people, and then was able to compute the parameters of a neural network and execute the task. As people, common people, taught to the robot, and not with an algorithm written with variables, equations, and so on, as we were discussing before, for instance, during the coffee break. So, this change, evolution in the marine robotics technology led to a change of perspective and is leading to a change of perspective from seeing robots, from tools, instruments to services. So we have basically better industry, marine science, citizens that were in some way called adapted as beneficiaries of end users are transforming themselves in co-developers and so move from multidisciplinarity to interdisciplinarity. This is a process, an ongoing process in that. We started it about 5 years ago, for instance, inside CNR in our Institute of Marine Engineering, together with our colleagues of the Institute of Marine Science. And so we are in our Institute of Robotica. There were naval architects working on ship and marine science. And we start to work together in an interdisciplinary way. So things are changing. And so we have, from the point of view of industry, the need of investment and methodologies. From the point of view of scientists, marine scientists, autonomous data acquisition. If you look at the citizens, AI, training, maneuvers, and data science. And also, now there is this idea of having a digital twin of oceans and of platforms working in oceans. So we have all these big models to be developed, but all of them has one thing in common, that are data. So we need to collect data and to share data in different fields for different people. So basically we moved from a vision that was, for instance, when developing a robot, writing a control system and so on, our activity was basically driven from the fact that the robot has to maneuver in this way, has to solve the task of auto-heading, auto-depth, following a path and so on. No, now the vision is data set. So it is also, from my point of view, as a navigation guidance and control system developer, writing software and so on, it is completely different because I started now to write a new version of the software for our robots. We changed the perspective. We started from the data, and we will see the idea that we are working on in how to implement this. So, when talking about data management, you have this magic acronyms, very fashion now, that is FAIR. FAIR is for findable. Metadata and data should be findable for both humans and computers. Interoperable. We need to work with applications or workflows for analysis, storage, and processing. Accessible. Once found, users need to know how the data can be accessed. And also reusable. The goal of FAIR is to optimize data reuse via comprehensive, well-described metadata. But FAIR does not mean open, does not mean free of charge. You can have FAIR data and then to ask money to people for using them. But you need to provide all this information. A colleague of mine working more focused on that looked at what happens usually. When people ask, for instance, to authors of papers, you wrote this paper, you said you have data available, please, could you send me the data? In many cases, the answer is, oh no, sorry, I cannot. And the reasons are great. In many cases, they lost their own data. People moved to another job. Some people died. And you have a lot of cases. But the percentage of results say, no, we are not able. It's quite high. And it took a very nice picture of how we collect data. See, okay, they are available with hard disks and USB pens inside inside the office. It is something that also ourselves, in a few years, lose completely the trace of how we keep our data. We need to do something. We need to change our way of working. So, we talked about metadata. And there are global metadata. They are domain agnostic. they are the same for any scientific discipline you use. And they are different in the title, the abstract, conventions, dataset start time, end time, PI name in any institution, place where you collected them, and the project, the platform, the dataset person, which kind of license you have for that, there is for data use, and so on. And there is also something specific that is standard name vocabulary. The name of the control vocabulary for the variable standard names that is meaning. So we need to have names such that if I say temperature, I mean that temperature. If I say longitude, I mean that longitude of that geoid and so on. Otherwise, it's a nightmare. And we need to use this kind of vocabulary. Then there are variable metadata that are domain dependent. So the nomenclature used for metadata and for the description of variables and their attributes has to comply, as I said before, with a control vocabulary. That for any given discipline ideally contains the standard names of all the variables that can be stored in a fair dataset. We need to know anything. And if we look at that from the point of view of a programmer, software programmer, we can see it as a type of the data and having a very clear and univoc description of what this standard name is. So we see an example of a log file of a robot. We have the standard name that, for instance, is latitude and longitude. And this standard name is given by the adopted vocabulary. Then, inside this log file, we can give a name to these variables. For instance, we have two robots, so we can have robot 1 and robot 2 latitude and longitude and so on. And for instance, it is a robot latitude. And log name is given by the user, by the who is reading the data. Then, of course, we have the values at time t of all of these variables. So, and this is given by the robot NGC system, because at each time it will provide a row of this dataset with the latitude, longitude, and depth and other values. So we said, okay, which can be the sources for establishing a marine robotics vocabulary and to propose. First question, if something exists, don't they increase the mass, use something that already exists. We don't want in any way to have a vocabulary with our name. If there exists something before, it's better. We have not to make the jump. We can go on. So does a vocabulary exist whose standard names include all is the key word here, the ones needed by marine robotics? And if it does not exist, how do we choose additional names that we call long names because they are not inside the standard and are at this stage proposed by ourselves? In science, it exists the climate forecast metadata conventions with the climate forecast standard name table. From the point of view of ship in the world of ship architecture, there is the International Turing Tank Conference that establish each year an ITTC symbols and terminology list. From the point of view of cybernetics and roboticians, all of us, I see, look at some of the students here, they are working on that. All of us have a reference that is basically the book by Posse. So we started from this. In earth sciences, where it is more formalized, is the climate forecast convention. That is for atmospheric chemistry, atmosphere dynamics, carbon cycle, cloud, hydrology, ocean dynamics, radiation, sea ice, and so on. The CF metadata conventions are designed to promote the processing and sharing of files created with the NetCDF API. So there is, if you have the data mean following these standard names, you can you have open tools to process data, to save data in files, to be open the data to gather metadata and data. And there is this climate forecast standard name table. And it is available on the network. You can check it, you can access it, consult it, and it is completely open. The Network Common Data Form, NetCDF, is a set of software libraries and machine-independent data formats that support the creation, access, sharing of array-oriented scientific data. It is also a community standard for sharing scientific data, and supports and maintains NetCDF programming interfaces for different languages, the common languages that we use, and also for other systems as now more common as Python, MATLAB, R, and so on. We have the data in NetCDF format has a lot of very well properties, self-describing, portable, scalable, appendable, shareable, and actionable. And you can find everything on the network, and they are maintained open. And there are also guidelines for the construction of CF standard names. So if you want to build, because you need something that is not inside this convention vocabulary, you are asked to build the names, the new names, following a standard. So for instance, the direction of the spatial component of the vector is indicated by one of the words upward, downward, and northward, southward, eastward, westward, or this one. The last two indicate the directions along the horizontal grid being used when they are not true longitude and latitude. So for instance, if in robotics we work in a local Earth fixed reference frame, and commonly we use X and Y, we have to call the variables using X and Y and not northward and so on, because these are strictly related to longitude and latitude. So there are also some generic names that are used with consistent meanings and units as elements in other standard names. Also, they are themselves generally chosen as standard names. So, these are not standard names. Speed, probability, pressure, mass, frequency are not standard names. We need to, in some way, specify them with the physical quantity they are related to, they are linked to. So we have an example, for instance, of temperature. Temperature could be the temperature of everything. So there is seawater temperature. But if you read this description, it is very specific. And so you know that seawater temperature is bad. You can go to the web if you are interested in check different variables. You can, for instance, look for temperature and you find a long list and see all the differences and so on. But go back. Okay, this is the framework where roboticians do. Okay? Are there robotics related standard names? We check the categories. I mentioned it before. No, there is not a robotic category. Okay, so there is a search button there. We made specific searches for robot, vessel, ship, and boat. These searches provided no results. We searched platform. We obtained results. A platform is a structure or vehicle that serves as a base for mounting sensors. It's a carrier, as a multidisciplinary approach that we mentioned before. Platforms include, but are not limited to, satellites, aeroplanes, ships, buoys, instruments, ground stations, and buses. Okay, we can extend this list with marine robots. It is natural to do that. So we say, okay, when there is platform, if we have variables, standard variables for platforms, we can use them for our marine robotics. So then, for latitude and longitude, you have standard names, projection is coordinated, y coordinate, and for that, you have a specific variable not related to platform. I mean, not with having platform inside the standard name. For instance, for the surge rate, that is the velocity along the axis, longitudinal axis, from stern to bow of the vehicle, you have the platform surge rate. You have also platform surge rate aft and surge rate for that specify also the direction in which it is moving. But they exist. These are standard numbers. Also for sway rate, that can be generic or import direction or starboard direction. In our case, when usually in marine robotics we put we put a frame on board the vehicle with the x-axis forward for the y-axis starboard and the z-axis downward. So in this case, usually we use platform surge rate for and platform sway rate starboard. You have also course and speed. So platform course is the clockwise angle with respect to north of the nominal forward motion direction of the platform. That is not necessarily the same as the direction in which it is pointing. That is called platform orientation. Because I can point in this direction, but there is a current, and so I don't move in this direction, but I am moving in this direction. And we have a platform course in this case. Platform orientation is the orientation of my boat, and in this case it is measured for example. We have the platform speed with respect to ground, WRT is with respect, and in the case of marine vehicles, the platform speed with respect to seawater. Because all the hydrodynamics of the vehicle is with respect to the seawater and not with respect to the ground. But platform surge rate for with respect to the water, to seawater, and platforms where it starboard with respect to water that are needed when we describe the dynamics of the vehicle are not included in CF standard rating. So our vocabulary should include them as long names, and we can build them in this way that follows the guidelines given by CF for building this long names. When we consider dynamics and we have a robot, it is important to know the force and moment we apply to a robot. Of course, if the robot is a carrier, when you collect the data, you want to know where it is, but it is which force is exerted by the thrust of this carrier is not important for you. So it was not included in the CI standard. But for instance, ITTC symbols and terminologies includes force and moment. We have them, we have their measurement unit, and so on. And so we have also to propose to add, again, platform search force forward, sway force starboard, if force down, roll moment, each moment in the moment, following the guidance for construction of CI standard names. Using as sources, and also for the description of these long names, what we find in the ITTC symbols and terminologies. So, our goal is to have a robot that is fair. I mean a robot that generates fair data. So the goal is to have the telemetry of the robot, telemetry file of the robot is built in this way. So we have a log trace.csv file with the telemetry data in the form of a roll-up table that is provided in this case by the swarm people. And the conf.image file with the descriptive metadata. And then we developed a set of JSON and Python tools to process this data and make them available for being stored in a data set that are can have a DOI and be published on the web. We have, there is this paper published on National Scientific Data, and basically we are at the beginning, and we are completely open to input from other researchers. So these are, from this point of view, we are at the beginning as marine roboticians, and we need to understand better how to do this, how to improve this, which variables we can put, how to describe these variables, if the names that we suggest are the right ones, and so on. But we need to establish a vocabulary of doing that. Because, for instance, if we make some, we collect some data for identification of the vehicles, and we adopted some algorithms for processing them and having the parameters. It should be open to everybody to collect this data, maybe collected 5 years ago, and you need to know what exactly there is in each column, and you need to have open procedures to process this data, to extract the data of interest, to post-process them in some way. And the idea is to have a place on the web where to share all the Python scripts and so on that people can develop and share all together. Try to have a community working together on that. And so go back to the slide at the beginning. So we have again, now we have this log and trace CSV5 construction that is made in this way. And we move, the work we did was to work on the long names, to propose long names that for the variables that are not included in existing standard names. Then we have to propose a way for constructing long names. For instance, when you have a navigation guidance and control system, for the same variable, you have the measurement value, the estimation, and the reference. So the idea is to say, okay, we put before estimated latitude, or measured latitude, or measured longitude, and so on. But this can be provided, measured also by different sensors. And so the name of the sensor for measured, we can put it at the beginning again. And so to have the GPS 1 measure the longitude, GPS 2 measure the longitude, and so on. And in some way, maybe the conf.ini file, we have to specify which are the characteristics, the data sheets, basically, of these different models of GNSS system and so on. But this is basically work in progress. So this is what we are doing, and we are proposing for having fair data in marine robotics, and facing one of the problems that was pointed out by one of the questions at the end of the previous lesson. So thank you very much for your attention for that, and I don't know if you have any questions. Probably we have time now.
Yes, we have time for questions. So,
yeah.
For ship rebuilding, we're using ROS, robotic operation. I don't know if you have interacted with that. That's standard format.
I'm sorry, what?
ROS.
ROS. Yeah, we worked for that, but we developed our software. We know that ROS exists. But this is our goal for that is to have something that, of course, can be also supported by ROS. But this is where you save the data, and to have some procedures for handling them, and to know that somewhere you have one name for that. And the goal, also from the beginning, is to have something that is also strictly related to what marine scientists did. Because many times they could, one thing could be, one possibility is not only for roboticians, because for instance, you collect data with your robot, and you have and you look not, and of course you have all these data sets that put together in some way. Maybe it would be easier to have to separate files, because so you can avoid to upload huge files and so on, but they can be merged and then go together. And maybe you look at some variables and you see, okay, here I have an anomaly. What was the robot doing when it was collecting those data? So there are all these variables, and they have they should have the possibility of working, accessing all the data of the robot. Of course, there is a part of this data that are used by robotic researchers, of course. And in any case, we would like to say, okay, it is not something related to the fact that if you use Python, you use ROS, you use another middleware or operating system. It is something to say, okay, we have a vocabulary that is very easy to translate in a format that is compatible with this vocabulary. The file that you save in your own system, and to save also in this one, because basically if you have a table, you have to write the first two rows, and it is something that everybody can share and use. This is basically the idea. Yeah?
How much space does a data set usually take?
How much?
How much space? Storage.
So now, of course, it depends from the length of your mission, because we save the data at 10 or 20 Hertz for the telemetry of the vehicle. And in any case, it is not too big. Now, it could be some mega. for the robot, even if you put everything there. And I mean, for 2 hours of work or something like that. And now it is just a bit different from some years ago when I started, because as you see, we save everything in a text way, also with names for variables that are quite long. But why not? Because now we have the possibility of transferring the data easily, the possibility of storing the data easily. One question that is open, and there is a discussion also inside our group from people with different backgrounds, because, for instance, when we talk about, for instance, surge rate, if you come from the control world, it is U, and it is only one letter. Because if you look at the fossil unit and everything, it is U. U is surge rate, C yaw angle, P is roll rate, and so on. So we don't know, myself and my colleague from the control point of view, we would like to have M underscore U, at underscore U, and ref underscore U for measured surge rate forward and estimated surge rate forward and reference surge rate forward. Because for us, we are used with this shortened way of representing that, and so we have to we are discussing which to say log name give to the variables, to our variables, of course. And I think it is natural that this debate is open for that. But probably if we wanted to be open to share data also with people and researchers with other background, it's better to write some more letters there. Yeah.
I think that the ETL process is so large to make it on the data recollection on the historical information. What do we do with the outliers information?
What?
The outliers information that the data that you don't use. What do you do before?
Outlier?
Yes, outliers.
Okay. For outliers?
Yes.
No. So this is these are the data collected by the robot, of the robot telemetry and so on. So you have a raw data. Then one part and of the job that we have to do, I think, as a community, is to say, okay, for instance, we can post-process this data to provide data sets that have not outliers. And in this case, okay, we give it, and you can also share with others in an open way the Python script, for instance, to clean them and so on. But as a robotician, for us, we have something different from processing data from the point of view of marine scientists. Because usually in many cases, marine scientists, they have data after the mission and they process them. What we need to do for navigation guidance and control of the robot is to process data in real time, because we need the estimates to move the robot as we want. And in this case, it is important to save and to provide also for developing better algorithms for the future, outliers. Because you have problems when you have outliers. The outliers can induce error in your navigation system. So, of course, probably if the marine scientists will use the CTD data of the robot, they will extract only the estimated columns, because they don't need all the others. But maybe if they wanted to improve the estimation of the position of the robot and so on, having on the basis of all the data available. So without having a causal filtering going only in one direction of the time, but being able to see what there is on the left and on the right of the data along the time axis, they can take all this data and then have a new estimate of the decomposition, for instance, that is better, probably, but can be done only post-processing.
You process all the data every day, everywhere.
Yeah. But, so it is important to provide fair raw data for us. And then, okay. Also because we will see also it better tomorrow. We need to process data in real time to control the motion of the robot.
Let's say that I'm a marine biologist and I work with you, and I want to work with the videos of the ROV. I have basic knowledge of coding. When I receive the videos, the metadata of the videos will have latitude, longitude, or that will be in another file, and I will have to merge video with
so
the
we
file.
are thinking about that also, because one thing could be there are different options, and I can start for what we did on VHS. We connected a serial link to the audio stream of the VHS, and we coded the timestamp of the robot telemetry on the audio track of the VHS cassette. So this was a way of doing that. So you can put in the metadata, for instance, to say, okay, when I created this video, I will put the time, and then you say, okay, and so you can reconstruct everything. If you save your images as images, you can put in the metadata of the JPEG. You can also do something that could be useful for the people without going inside, saving the images with the names. And we have to understand what it is better, also how you process that. So if you have suggestions, we are completely open. Because probably you can, if it is better for you to have a latitude and longitude, or to have the time in the name of the, if you have, for instance, if you have pictures, because in the metadata inside you can put everything. But for instance, I know that I am interested in that location. So probably I have a lot of images. I don't want to go inside each of them. I want to put it in the name of the image, probably. So what it is better to put in the name of the image? Because we can do it, it is easy. Maybe we can put latitude and longitude. We can put a latitude, longitude, and time UTC probably, and so on. But we have to define it in one way.
Yeah, for me, I get all the time, I use, for example, the GPS on the surface, and I go diving and I look for it. So then to merge the GPS with the video, it's kind of tricky because when the metadata that the video makes just print the hour of the beginning, and then you have to use the timestamp. But for example, once we find a camera that was making video, but also was recording depth and pressure and also temperature, and make a separate, comma-separated file.
Yeah.
And we use that file to merge GPS with the video at each moment.
Yeah, okay.
But that was
you can
have those.
Yeah, and you can also write Python scripts to put different CSV files together, of course. And for instance, but also when you look at that, in many cases, so if you use videos for motion estimation, so for algorithms of visual surveying and so on, probably we need a higher resolution in time and also in space, because we need a certain hertz for each image. If we move on 1 centimeter, it is quite important probably if you are in this place, okay, if you are in a centimeter, it is not a problem. So to have the starting time and having the GPS, I mean, the latitude and longitude of each image is okay. For us, for the robotic, for developing vision processing algorithms, we need more. So we have to stress it more because we need to have the image associated to the right row in the logging of the telemetry of the robot. So if there is an error of 0.2 seconds, for our goals, it could be a problem. So probably for you, if you have a robot moving in 30 centimeters per second very close to the seabed, if you have a delay, a shift of 0.2 seconds, it is nothing. But so for us, the constraints are more strict. So, okay. Any other questions? Quanto abbiamo? Perché com'è il programma?
Devi fare poi la seconda fino abbiamo tempo fino all'1 se vuoi. Però se vuoi ricordare in 5 minuti.
Allora, un attimo, facciamo 5 minuti di pausa.
Sí, hacemos 5 minutos de pausa y más que nada para el docente.
Sí, sí.
Para que descanse.